Hello friends, once again welcome to this video classes. We have already seen t-test, and today we shall learn another test called Pearson product moment correlation. Pearson product moment correlation. Now as you can see, what is this Pearson product moment correlation test? Pearson product moment correlation test is once again a parametric test, and if you can see here, there are three possibilities in any correlation. One is a positive correlation. Positive correlation means that the curve goes upwards, which means when one mean increases, the other mean also increases. Okay, so that is positive correlation. And what is negative correlation? Corresponding to the declining of one mean, other mean also decreases. So that is negative correlation. There is correlation, but it's a negative correlation. As one mean decreases, other mean also decreases. And then there is the third possibility, which is curvy linear correlation. In other words, as one mean decreases, other mean increases. Corresponding to the decrease of one mean, another mean increases. So that correlation is known as curvy linear. But when we speak about Pearson product moment correlation, we are only speaking about these two possibilities. Either it is positive or negative. There is no curvy linear correlation. So that we must understand at the outside. At the beginning itself, we must have clarification about that. So Pearson correlation is symbolized as rho, the Greek letter rho, or sometimes even the letter R also is used. English letter also is given. Basically it is known as Pearson Rho. Okay, Pearson Rho. And it varies from -1 to +1. So correlation, always the results you should get between -1 to +1. So you cannot get a result which is above 1, or you cannot get a result -1, like you can't get -2 and so on, or similarly you can't get a result +2 and so on. So it has to be between -1 and +1. So that part we must understand. So what is this -1 and +1? So it basically speaks about the strength of the relation. How strong is this relation between the two means? Okay, two variables. Of course, we are comparing the means here, means of two variables. So which means that if the relation is strong, we must get a little higher value. If the relation is not so strong, you will definitely get a lower value. So that's the meaning of strength of the relation. For example, let's say if you get a result between 0.40 and 0.70, so that relation is known as a moderate relation. So that the relation can be, the strength of the relation can be considered as a moderate relation. On the other hand, let's say if you get a value which is above 0.70, it could be called as substantial. And let's say if you get a relation which is till about 0.90, it is considered very significant. Okay, and if you get result or the value between 0.90 and 1.0, if you get results anywhere between these two values, and that relation is known as a very perfect relation. That is a very, very strong, perfect almost correlation between the two variables in terms of their means, which means something is affecting a change in the other. By the way, we must clarify here, it is affecting a change in the other, but which is affecting the change in the other, we do not know. So that part is not spoken by this Pearson correlation. It doesn't say. Now, for example, let's say our famous example, if you were to say, because of the use of mobile phones, the grades have come down. Now it is possible that mobile phone, because of the overuse of mobile phones, the grades have come down. It could also be possible that grades have come down, and because of grades have come down, the mobile phone usage has gone up. So, which is affecting the change in the other? That part is not clarified by this test, this correlation test. But it only says that is a strong correlation between the two, similar to, let's say, chi-square and t-test and others. So that part we must understand at the very, very outset. Okay, so coming back to this Pearson correlation, only it is, which data does it use? It uses, as we said, because it is a parametric test, it uses only interval and ratio level data, as you interval as well as ratio level data. So because it is a parametric test, whereas a non-parametric test will use nominal and ordinal data for comparison. Okay. Now, what is the formula for this Pearson product moment correlation? The formula rho is equal to n sigma xy minus sigma x into sigma y divided by root of n sigma x square minus sigma x whole square into n sigma y square minus sigma y whole square. So it may look a little complex, but actually it is very simple. Now x and y are nothing but two variables, first variable and second variable. So everywhere you have x and y. Of course, variants are there, but it is basically the two variables. N refers to the number of pairs. Now, how many, the total number of pairs that you have? So that's the value of n. So that part you must understand. Maybe we can pick up an example so that you get a greater clarification about how to get this Pearson product moment correlation test done. Now here is an example as to how two students have got the rank in various subjects. So they have undergone exams in about 8 tests, and how these two students are getting the ranks. Now if you can see in their subjects, they have got these ranks. The first student has got ranks like this, second student has got ranks like this. So we do the test. Now I'm continuing with the application. Of course, you know the formula already, which I showed you just now. Now you do the xy first of all. Xy is nothing but multiplying the two scores. 1:1 is 1, 2:2 is 4, 3:3 is 9, and so on and so forth. 8:6 is 48. Now here you also get this sigma x. That means you total the whole thing and you get sigma x, which is 33. Sigma y you get by totaling the second variable. So sigma y is 29. Okay. And sigma xy, you total the multiplication of x and y, you total it and you get sigma xy, which is 145 for this test. I mean, for this problem, the sigma xy is 145. Then you also do x square, because this also we require x square. Now x square, how do you get? You just multiply the first variable, multiply, or rather not multiply, but you square it. So 1:1 is 1, 2:2 is 4, 3:3 is 9, and so on and so forth. Finally, 8:8 is 64. So you are squaring the first variable. So that is x square, and then you get sigma x square, which is the total of x square, which is 171. Similarly, you also do the same thing for the second variable. You square it, and you get similar results. 1:1 is 1, 2:2 is 4, 3:3 is 9, and and go on like that, and you get 60 to 60 is 36 for the last subject. And then you do the math for sigma y square, which is 125. 125. So you have got the basic data. You got to x, sigma x you got, sigma y you got, sigma xy you got, and then sigma x square you got, and sigma y square you got. But you should also get a few more data. If you can see, sigma x square into sigma x whole square is there. Similarly, sigma y whole square is there. These two data we are yet to get sigma x whole square and sigma y whole square. Now, sigma x is 33, so you need to get 33 whole square and 29 whole square. That we have not done, so let's do that also. If you can see here, sigma x whole square is 33 into 33, which is 1089, 1089. Similarly, sigma y whole square is 841. Why? Because 29 into 29 is 841. So you got all the basic data that you needed. Now you put the entire data that we have calculated into the formula. So what is the formula? Once again, let me go back to the formula. This is the formula, if you can see. So it's n sigma xy minus sigma x into sigma y, root of n sigma x square minus sigma x whole square into n sigma y square minus sigma y whole square. So as you can see here, 8 into 145 minus 33 into 29 divided by root of 8 into 171 minus 1089 into 8 into 125 minus 841. So I have just put the whole thing into the formula. Okay, whatever we received there, you have put it into formula. So you get like this results. You can see the results like this. So if you can see 203 divided by root of 279 into 159, and finally you get results like this: 203 divided by 210.62, and the results you get is 0.962. So which means which is above 0.9, which means there is a very, very significant correlation between the two variables, which means the way the first, that means a positive correlation. The more the first student gets the ranks, it's likely that second student also gets similar ranks. So there is a very, very high correlation between the two. So that's what we come to know. The more the first student gets better ranks, the second student also gets a better rank. So that's what we come to know from this test. And we can say there is a positive, strong correlation between the two variables.